Hello, this is Mr. Huber. In this lesson, we're going to learn about solving multi-step inequalities. So these will be inequalities where we have multiple, more than one step to solve them. For instance, we might have to add or subtract on both sides and also multiply or divide on both sides. The goal is to get that variable by itself by using inverse operations to isolate the variable on one side of the inequality. So let's see what that looks like here with some examples. So our first problem, 2x minus 5 is greater than 23. So we're going to solve that by first adding the 5 on both sides. We're trying to get the x by itself, so that gets us 2x greater than 28. And next I want to divide by 2 on both sides, so the 2 over 2 cancels out to 1x is greater than 14. And if I want to graph that, because we're going to solve and graph, so when I put this on my number line for the graph, that'd be 0, 5, 10, 15. At 14, I'm going to have an open circle. So I'm going to have 14, I'm going to have an open circle because it's not equal to, it's just greater than, and greater than will be to the right on my number line. Number's bigger than 14. And if I want to check, I could take a number that's bigger than 14, like 15, and I could plug it back in here. So if I take 15, for instance, and put it in here for x, 2 times 15 is 30. 30 minus 5 is 25. 25 is greater than 23 would be a true statement. So that shows that it looks like my answer's on the right track there for solving that inequality. In number 2, negative 16 is less than negative 6y plus 5. So we're going to solve that by subtracting 5 on both sides. We're trying to get the y by itself. So we have negative 21. Careful with our calculations with negative signs. Then we're going to divide by negative 6. And we're going to have a positive 3.5. And we have to switch the direction of the inequality because I divided by a negative on both sides. I divided both sides by a negative, so I had to switch the direction of my inequality. When I do that, I'm going to get 3.5 is greater than y, or you could rewrite that as y is less than 3.5. It doesn't matter, you don't have to, but if it helps because you have a variable on the left, when you go to graph it, that's fine with me. So 0, 1, 2, 3, 4. So we have 1, 2, 3, 4. Between 3 and 4 is where my 3.5 is going to go, and I'm going to have an open circle at 3.5, and less than, so I have an arrow going to the left on my number line. All right, and number 3 here, I want to see something with a fraction. And you can handle this in a couple different ways. You could distribute the negative 1/4 into the parentheses, or you can multiply both sides by the reciprocal. I'm going to do that. I'm going to multiply by negative 4 over 1. A negative times a negative, that cancels that out. I'm going to have p minus 12, and on this side I needed to multiply by negative 4 over 1. That's a positive 8. And my inequality is going to switch because I multiplied by negative 4 on both sides. Since I multiplied both sides by a negative, I had to switch the direction of my inequality. And now I can add the 12 on both sides. So when I add 12 to both sides, I'll get p is less than or equal to 20. And I could graph that on my number line. 0, 5, 10, 15, 20, say there. That would be 25. And so we're going to have a filled in circle this time because it's less than or equal to 20. Since it can be equal to 20, we include 20 and then all the numbers less than 20. All right, we have one more here, number 4. 5x minus 12 greater than or equal to 3x minus 4. We have a variable on both sides of the inequality. I would always encourage you to get the variable onto just one side first before we worry about any of those other constant terms. So I'm going to have 2x minus 12 greater than or equal to negative 4. And then I'm going to add 12 to both sides because I'm trying to get that variable by itself now on the left side. 2x is greater than or equal to 8. And then when I divide both sides by 2, x is greater than or equal to 4. And so I could graph that on my number line. I had 3 steps in this one, so multi-step means some number of steps. It's more than one typically when we talk about a multi-step. So I have 1, 2, 3, 4, 5. And at 4, I'm going to have a filled in dot because it does have the equal to and greater than arrow going to the right. So get the variable on one side of the inequality, isolate it by itself using those inverse operations, and then you have the graph for it on your number line. Open circle when it's not equal to, filled in dot when it can be equal to, and then make sure you know if you're picking numbers less than or greater than when you put them on the number line. Like what can happen with equations, we can get an instance where a variable cancels out on both sides of an inequality. We saw that in the last example where we had to move the variable to one side or the other because it was on both sides. Sometimes when we're doing that, it might cancel out. So when that happens, we get one of two situations. If the variable cancels out on both sides and we get a statement that looks something like 5 is greater than 4 or 8 is less than or equal to 8. These statements are true. 5 is greater than 4, always true. 8 is less than or equal to 8, always true. That's when you get all real numbers. So that's all real numbers. Okay? A statement that's always true. If the variable cancels out on both sides and it's a statement that's never true, like -1 is less than -3, or something that's never going to be true, so that's never true, you get no solution. Okay, so no solution is when you get the variable to cancel on both sides and you get an untrue statement. All real numbers is when the variable cancels on both sides and it's always a true statement. And your graphs will look like they do here. All real numbers, everything on the number line is a solution. No solution, you put a number line, you don't draw anything on it because there's no numbers on there that will work. So be aware of those two special cases. Let's see what it might look like here in practice with these two problems. So in number 5, we're going to start by distributing the 5 into the parentheses on the left side. We have 5m plus 25 is less than 5m plus 17. So I want to subtract 5m on both sides because I'm trying to get the m onto just one side of the inequality. Well, it actually cancels out on both sides. At 0 plus 25 is 25, is less than 0 plus 17 is 17. That's a statement that's never true. 25 is never less than 17, so this is going to be no solution. No solution, a statement that's never true. Let's see the next example here when I'm going to distribute the -4 into parentheses. I'm going to get 1 minus 8y is less than or equal to -8y plus 4. And so now when I add 8y to both sides, because I'm trying to get the y onto just one side, I'm trying to cancel out, it actually cancels on both sides. And I get the statement 1 is less than or equal to 4. That's always true. That's all real numbers. Okay, so we want to be aware of those two special cases where we can get no solution or all real numbers, depending on if the statement comes out to always be true or never be true. All right, before we do some more inequalities, a little elementary humor break here. So why was Tigger looking in the toilet? Why might that be? Well, as we can see here, it's because he was looking for poo. That's right, that's why Tigger was looking in the toilet. And why is Cinderella so bad at soccer? Well, as we know, she always runs away from the ball. All right, there you go. A couple of lighthearted elementary jokes. I'll let you calm down your laughter here before we move on to some more inequalities. So when you've composed yourself, let's go to another problem here and apply what we've been learning about compound inequalities. All right, so you're saving money to go to summer camp. It costs $1,800. You've saved $500 so far, and you're going to save for 14 more weeks. So you're going to save a certain amount of money every week. And you're trying to figure out what's the average amount of money I could save every week and have it be enough for me to go to the camp. So we're going to write an inequality for this. So I would have the $500 that I've saved so far plus 14 times however much I'm going to save every week. And I want that to be greater than or equal to $1,800. All right, so I want to make sure I have at least $1,800. So I could have more than that, or if I have $1,800, I'll pay for it exactly. Okay? Then I have the $500 I saved plus however much I'm going to continue to save every week. Right, this is the amount I'm going to save for every week for 14 weeks. I want to find out what that average would be. So now I'm going to solve this. So I can solve this by subtracting 500 on both sides. And I'm going to get 14x is greater than or equal to 1,300. Right, that cancels there. So now I'm going to need to divide both sides by 14 because I want to get the x by itself. So when I take 1,300 and I divide it by 14, then we're going to round that answer off a little bit. And let's write out the step there. So I'm going to divide by 14 on both sides. Okay, I'm going to get x is greater than or equal to, and when we talk about money, we go to two decimal places. So we'll say 92.86. It's 857. We round that up. Right, we're not going to have less than pennies, so 86 cents. So you'd have to save more than or equal to $92.86 every week. So you could say I'm going to try and save $100 a week or something that's at least the $92.86 every week. If you got a little extra, great. You got a little more money for something else at camp, or buy yourself some bacon or another nice treat. All right, so we can write out an inequality that goes with this situation. Keep in mind we want to save at least $1,800, so that means that much or more, and we can solve that. And then just be realistic about the answers you get when we're talking about money or other different things. Where should we round to? So sometimes in those real world scenarios, we don't have to be told. We can recognize, oh, money, we go to this decimal places, or if it was whole numbers we could only use, we wouldn't want to have parts of something depending on what we're solving for, right? We can write that out properly to answer that real world scenario. So we would save at least $92.86 per week. All right, so solving multi-step inequalities, we're still trying to get that variable by itself. We're just going to do a couple different steps within problems, simplifying, getting variables on one side of the inequality, and isolating them to find out what they're less than or equal to, greater than or equal to, and then also when they cancel out on both sides of the variable, look for those special situations, no solution, and all real numbers.